Okay, good morning. Welcome all. Thank you for joining my talk on the serverless cloud. Just before we begin, one quick question. Who had too many beers last night? Ah, great, I'm not alone. Good. I'll start with a very short introduction about myself. My name is Bart Blommaerts. I live and work in Belgium at Ordina, more specifically in the JWorks business unit. So we're a Java and JavaScript consulting company. If you have any questions for me, remarks, or whatever's on your mind, you can reach me on my Twitter handle. And since this is being recorded, I'm also going to use the opportunity to thank my 4-year-old son for his giraffe. It's going to be bring me a lot of luck. So he's going to be very happy when he sees that. Probably doesn't care about the rest of the talk. We're here about the serverless cloud. So what is this serverless concept? And another quick question. Who in the room has already been reading or using serverless? Ah, no one. Awesome. I will be able to tell you whatever I want. Great. No. Now, before we start with serverless, I have a couple of more questions for you regarding some known topics. For example, infrastructure as a service. Who uses these on a regular basis? So, for example, Amazon Web Services or Google Compute Engine. Okay, that's a couple of you. Next up is platform as a service. So who's using this regularly? So I'm not asking if you know what it is, but if you're really using it, like Cloud Foundry, OpenShift, show of hands. A bit more, but not that much. Okay. To explain serverless, I would really like to start with like a comparison. A lot of other speakers have already mentioned this guy. I'm pretty sure everybody knows who I'm talking about. There is a concept of clueless, and it means, well, not having a clue. So, serverless must mean not having servers, right? That makes a lot of sense. No? I think it makes a lot of sense. Unfortunately, or maybe fortunately, that's not true. It does not mean no more servers. I mean, we build applications, and the applications need to run on something, right? There are a lot of people investigating to bring bits and bytes on DNA, but trust me, we're not there yet, not at all. So there will be servers where our application can run on. And personally, I believe that serverless is like a next evolution in cloud computing. We have seen a lot of disruptive technology, and in my opinion, serverless is like the next step in that evolution. So if it doesn't mean no more servers, maybe it means no more worries. Because in the serverless world, we're not responsible for the servers. We will be outsourcing them to a cloud provider. They will take care of the security updates, scalability, availability. So, okay, less worries. That's somehow definitely true. However, if you're putting a lot of trust in a serverless supplier, well, that means that you need to know your serverless supplier very well. And I'll have a couple of examples on that later. There's also this common myth in the serverless community that it also means no ops, no more operations. Since we're outsourcing all of the servers to, for example, AWS or Google or Azure, well, they can take care of the operations for us, right? Again, no, not particularly. If you look at it from an application point of view, you're still going to need monitoring. You're still going to care about deployment, security, and everything I wrote down on there. Very interestingly, just last week, on Wednesday, I was at a conference and somebody from Google was saying, yeah, there's no operations. We know that we're not there yet. Might be a goal in the future. So well, there's a lot going on in this particular area. Now, if you're like a developer with a certain operations mindset, this is really an opportunity to build cool tools. There's not a lot yet available in the open source or in our community regarding tooling. So if you think, I really believe this serverless movement and I want to spend some time on it, there are a couple of projects already open sourced on GitHub. You can find them and you can really contribute to them. Now we have established that serverless might not be the best name for what we're doing. So some very clever people on Twitter came up with an alternative, and that's FaaS, Functions as a Service. So let's talk about functions as a service more in depth. We have talked about what serverless is not, so maybe it's interesting to talk about what is serverless. Let's look at some key characteristics of a function as a service. One very important characteristic is event-driven. For the people who were at the conference yesterday, there are a lot of talks about event-driven microservices. It's really like gaining a lot of traction. And within functions as a service, within serverless, events are really like first-class citizens. Everything is an event. Obviously, this means that the code that we're writing, the applications that we're building that are composed of different services, just like with microservices, that a lot of external things can execute our code. For example, if we are integrated with AWS, we will have DynamoDB, so document database events. We can have S3 events. For example, putting a file on a server will be able to trigger any event. Next up, and this is really, in my opinion, really a differentiator for serverless, for functions as a service, it is pay-per execution. Now, management will definitely like the concept of pay-per execution, but what does it really mean? Well, it means that there are no servers running. When you execute a request to whatever URL that you're using, only at that specific moment in time, there will be a server that's being instantiated. I have a slide in a couple of slides how this works internally at the providers. So there is no running servers. This is really, you don't need to care about provisioning because there is nothing to provision. So it means that you only pay when your code is being executed, and this leads to small operational costs. As you can see on my next slide, this is an example with AWS. So in the logging, you can find that here in particular, the function that I was executing was running for 100 milliseconds. This also means that I'm paying for 100 milliseconds, which is really cheap. If you look at the pricing model from AWS, you will see that you get 3.2 million free seconds per month, which is really a lot. And even then, when you have more requests than this, there is a very small price per 100 milliseconds. Obviously, this is depending on your traffic. If you're executing millions and millions and millions of requests, then your invoice might still go up. But that's their model, and then there are some calculations done, and it's really one of the cheapest ways of having executable code today. I already touched on this briefly. The seamless scaling is also really a key characteristic of serverless. And it makes a lot of sense, because there is no server running. So if your serverless provider thinks, OK, I'm getting a lot of requests, I need to make sure that I can handle them, I'll just spin up a couple of new compute containers, and it will just scale for you. You don't need to worry about any of the provisioning. There is nothing running. This is like a key concept that's really important to think about. These compute containers are short-lived, so there are currently no specific service level agreements from the provider saying, OK, if you spin up this container, you will be able to use it for like an hour or 2 hours. We just say we will do our utmost best to make sure that your request is executed as soon as possible. This is important to think about because when you do a cold request, the container will start up the first time, and that will take more time than when you have a container running already. So you should not be dependent on the reuse of containers. Currently, right now, if you would investigate over a period of time, on AWS, the compute containers are running for 4 hours, but they can change it how they feel. Another characteristic of functions as a service is that it's stateless. And that's also pretty obvious because there is no state to preserve. There is no running servers. So if you want to make sure that whatever you're doing is preserved, you need to use something external, for example, a database, a file system, or a cross-application cache. For example, Redis can be very convenient in there. Most of us who have been working with microservices already know that they should be stateless, and the same goes for functions. The next one might be a bit controversial, but functions are easier. Within microservices, it's still very difficult to think about, well, what are we going to put in our function? What's going to be our bounded context? With functions, it makes a lot of sense. It will only be able to do one thing, one request, one response. Very easy. Obviously, if you want to write dirty code, well, you can always do that. So it's easier only if you really want to. That's a lot of talking. I have a quick recap. So functions as a service is less about server management. You're outsourcing that to a trusted provider. It is event-driven, and the events will tightly integrate with the provider we went with. Pay-per execution. the seamless scaling, stateless, and unless you really try your best to make it more difficult, it will be easier. Trust me on that. Now, we have talked about the concept of serverless. I'd like to make it a bit more concrete for you. And there are a couple of suppliers. I want to talk about the suppliers. My friend Pablo over here, well, is not really a supplier, well, definitely not of serverless. What we see in the community is that all of the large cloud offerings right now, so look at Google, AWS, they have really jumped the serverless bandwagon. They don't want to be left behind. They really believe that it should be tightly integrated with whatever they're offering to make sure that you choose for their service. And this to me means that this movement is gaining a lot of traction, and if all of the big partners are really jumping on it and working very hard, then it makes sense that it has a lot of value. AWS Lambda. Who has heard of AWS Lambda? Oh, awesome, most of you, great. Who thinks that AWS Lambda was the first provider of serverless functions? That maybe was not the best question. It wasn't. The first was actually Google, and it was many years ago. But they didn't gain a lot of traction with it, and they're now making a new offering to also offer serverless, where I'll talk about it in a minute. But AWS Lambda is definitely the most famous of them. They started it in 2014. And it integrates very nicely with other offerings from AWS. So many times when you use a Lambda, you will also be using the AWS API Gateway. And the API Gateway is another tool where you can define your endpoint and say, OK, this is how I want to trigger my Lambda. In the demo that you'll see later, I'm using the API Gateway, but I will also be using DynamoDB to stream events to Lambdas. Another one many people tend to like, which is kind of strange since IBM is not the most popular company in the world. It's OpenWhisk. OpenWhisk is built upon Bluemix, and Bluemix is the PaaS, the platform as a service from IBM. Now, what is really, really cool about OpenWhisk is that it's open source. It is fully available on GitHub. They even provide guides on how to set it up locally on-premise if for some reason you would like to do that. They're currently the only one who really has a data mature solution that you can also run on-prem. Something else that I personally find very interesting about Bluemix, about OpenWhisk, is their user interface. If you have worked with AWS, you know that the user experience on Amazon is maybe not that great, which is just a nice way of saying that it's terrible. And on OpenWhisk, it's really nice. You get a nice dashboard, you get monitoring tools. I'll be happy to show you that in a bit. Microsoft Azure Cloud Functions. Who over here has used Azure in the past? Who likes Microsoft? Could you fill maybe the room? Who likes Microsoft? OK, nobody really tends to be involved in their ecosystem. And I may be doing a very strange explanation right now, but you should look at Azure. Azure is really cool. The Azure Cloud Functions is also a very mature system that they're offering right now. They have videos, they have easy-to-use guides, they have open-sourced a lot of examples, so it's really worth looking at. One thing that I then don't particularly like about Cloud Functions is the fact that they keep on sending me invoices. So the payment model from Microsoft is very different regarding the model from, for example, AWS. And that's also very important. If you choose a certain provider, make sure that you understand their payment model. And the payment model is often linked to the sharing of resources. And it's very different between providers. Last one of the big companies is Google Cloud Functions. So Google did this serverless approach about 5 years ago, if I remember correctly. And they're now rebranding Cloud Functions. They're actually newly implementing it. Currently, Google Cloud Functions is in private alpha, which means that officially I'm not allowed to talk about it. Well, I'm not allowed to provide more information than what's already on their website. Since it's being recorded, I probably should not be saying what I'm about to say. But I kind of understand why it's in private alpha. If you compare it to Bluemix, to AWS, they still have a lot of work. On the other hand, if you look at their community forums, there is a lot of work going on. People are working very, very hard to make sure that when it leaves the alpha, it will really be a nice offering as well. I never said that, if anybody else asks. Now we have seen the big guys. One of the smaller offerings, and there are more, but I'd like to talk about Auth0, is WebTask. And what's really nice about WebTask is basically a command line interface for building, well, they call it WebTask, but it's functions. And the nice thing about Auth0 is that it's really, really simple to use. If you exit the room and you think, okay, maybe the serverless thing is something, I want to have a look at it, you should start with WebTask. In under 30 seconds, you will have a running cloud function with an API that you can call. If you look at their documentation, they will show you how you can preserve state within their system. It is really very easy to use, and it works very nice. I'll have a sip of water. Demo time. Who watches The Walking Dead? More people than that liked Microsoft. Okay. Now my demo is on collaborative economy, and I'd like to talk about collaborative economy briefly for a second, then you have a better idea of what we're trying to achieve with the demo. Collaborative economy means, well, it looks at the fact that a lot of companies, basically all of your employers or the projects that you're working on, they have a lot of data. They have huge piles of data. And, well, trust me, you're probably not using them very well. Management will look at the data that you have available in data stores, databases, whatever that you're using, as a cost center. And if you think about it differently, maybe there are some parts of your data that could be publicly available. So you can just create a small API and just make it publicly available on the internet. Maybe others will look at it and say, hey, this is something very interesting. I can use some of my data and then combine it with the other data, and maybe you can come up with something like that. Well, this is also very well, but if you're like a small startup and you think, oh, I don't have any data yet, great. Another thing that you can do is you can have a very good idea. There are a lot of companies that are already offering this data publicly available. I'm pretty sure that most of the governments do this. For example, in Belgium, there is the Open Data Project, and there's tons and tons amounts of data. I know in the United States that is really also a lot of data available. I'm pretty sure that it will be the same in the UK. And if you look at this data, the cool thing about this is that you can just combine it. You can combine information from one part, you can combine it with somebody else. And this is where like creativity will be able to add value. And I think that serverless is really something that enables this. Because I couldn't make it large enough on the slide, serverless enables experimentation. What do I mean by that? Setting up serverless means that you will initially have very few running costs, so the operational cost is very low. You're only paying per execution. And also from a development point of view, since it's rather easy, you can get started, well, in a cheap way. We actually have a company in Belgium that has no data whatsoever from itself, but they're combining data from others, and right now they're really booming, and everybody wants to use what they're doing. This is what we're building. For the demo, I have this Arduino, which was programmed by a couple of colleagues from me. It has a temperature sensor on it, and it's going to measure the temperature of the room. There's two buttons. One button will measure it once and send one post request to a web task in Auth0. The other button will continuously measure the temperature and send it to Auth0 web task. Now, what will this web task do? It will look at the incoming data, it will parse the data, add some data of its own, and then do a new post request to OpenWhisk. In OpenWhisk, they call it actions, but again, always functions. And OpenWhisk will do the exact same thing. It's going to look at the incoming data, parse the data, add some data of its own, and then do a new request to the AWS API Gateway. And this is where it gets interesting. The API Gateway will send an event to AWS Lambda. This particular Lambda, and I'm going to show you it in a bit, was created with a framework called the Serverless framework, and that's different from using it directly in AWS Lambda itself. It will parse the incoming data, add some data of its own, and then persist it in an AWS DynamoDB. I'm a big fan of DynamoDB. DynamoDB will look at the data, parse the data, blah, 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 add some data of its own, and then stream the event to a new Lambda. This Lambda is not created with the serverless framework to be able to show you guys the difference. And then finally, the last Lambda is just going to look at the payload that it received and log it in AWS CloudWatch. Okay. Before we start, One last thing on the serverless framework. This is a command line interface. It was actually nominated for the JAX London Innovation Awards. Unfortunately, it didn't win. And it can be used to create lambdas. Now, what's really cool about the serverless framework is that it already comes built in with a couple of best practices, like, for example, grouping of functions. This means that it's not necessary to deploy every function all the time, and without the serverless framework, that is necessary. And it also has complete lifecycle support. You can create your functions, you can deploy them, you can invoke them, you can remove them, and that's all from the command line. This is a big one. It will soon be supplier independent. So if you're looking at it right now, you might think, oh, but this is like really a vendor lock-in? If I go with AWS, I'm stuck with AWS forever. With the serverless framework, in the near future, you will be able to write it in serverless and deploy it in the serverless framework. For example, you write it for AWS, but deploy it on Azure. And there's actually people from Microsoft and from IBM who have already submitted pull requests on the serverless framework to make sure that they are also included in their deployment model. It hasn't been released yet with their support, but it's upcoming. It's really cool that really IBM and Microsoft themselves that are doing this. If you are interested in the code that I will show you in a bit, or in the Arduino, then you can just look them up on GitHub. Any questions so far? No questions? Okay. Oh, you're still not seeing it. Where is the... Oops. The mirroring options are not available. That tends to be annoying. Come on, good Mac, work with me. Okay, well, we'll do it differently then. For some reason, it's not showing the mirror options anymore. Oh, that's giving an error. That's always great if you're doing a demo. We'll see how it goes. This is the logging from the Arduino. So hopefully if I press the button, it's going to measure the temperature. And it's currently 22 degrees. I'm going to kill it again. So what happens now is that the temperature measurement has been sent to WebTask and all of these different hubs in the system. The first one I would like to show you is that's annoying. Is the Arduino itself. It has some cache showing what just has happened. I really should be able to monitor my screen because my neck is going to hurt otherwise. All right, that's a lot better. The resolution of the beamer is not great, but we'll get it done. So, why can't I resize it?
Window, maybe?
Yeah, well, I can see something. This is the OpenWhisk dashboard. So if you just log in into Blommaerts, this is what you're going to see. Again, pardon for the resolution, because there's a lot of text right now that's not very visible, but you get this inline editor on their website where you can just experiment with and then try to write your function. This one is written in NodeJS. Most of the suppliers are supporting NodeJS, but other languages are also supported. For example, AWS does Java and Python. Azure will do C# and F#, so there are a lot of possibilities. What's really cool about OpenWhisk, about Blommaerts, is that you can also run them from within the browser. So if you want to OpenWhisk your action, you have the possibility to add some JSON input. And if I can see the button, why is this not working? Well, there actually is a button here that said run, and then I could show it to you.
Isn't it Windows Zoom?
Awesome, thank you. Beers for the guy on the front row. So you can run it with this value, and if everything works great, it will show you what has just been executed. And here you can see that in this particular case, what we executed has been built for 481 milliseconds, because it was also running while contacting, for example, AWS. If you look at the monitoring from OpenWhisk, you get a nice dashboard. I will zoom in. Here, for example, you see that I've done 50 invocations and the average time that it's running. You can see you can do some filtering, and you can just have a view on what you have been executing in OpenWhisk. So it's a very nice dashboard, very user-friendly. I have to say I particularly like it. Next up, as we have seen, it will be the OpenWhisk action that is calling AWS via the API Gateway. If you haven't worked with Amazon yet, this is like their dashboard where they have all of their services. But that's not what I wanted to show you. I actually haven't opened it. OK, let's go there. API Gateway. The API Gateway is a very nice tool if you want to have executable endpoints for whatever you're doing basically in AWS. Here in particular, we're going to execute the Lambdas. Now this is a different API, but I prefer showing this one because it contains a lot more endpoints. And then you can easily see, OK, these are the operations that I want to execute. You can also test them, just like we could with OpenWhisk. If we hit the test button, I have a staging variable, for example, for our development environment. And then we can also test it, and hopefully we get a nice response. And over here you can see, this is also using DynamoDB. So this API gateway is calling Lambda, and that Lambda is just querying DynamoDB and outputting some really cool cars. Then there is AWS Lambda itself. Here you can see a list of all the functions, and you can also see the runtime that they're using. What's particularly nice if you compare, for example, NodeJS, you see that it's 23 kilobytes. OK, it's just demo code, it's very small. But if you compare it to Java, this is 33 megabytes. Now, the size of the function is also very important, because this will have an immediate impact on the execution time. If you start up a JVM, that takes some time. You're starting up in a compute container on AWS. It will just be a bit slower than it is when writing it in Node.js. Now let's look.
Does it affect the pricing as well?
It will affect the pricing. Very good question. So the question was, does it affect the pricing? Yes, it will affect the pricing because you're paying per execution. And if your execution takes 100 milliseconds, you pay something very small, the number that I showed earlier. And if it's longer, then you're going to pay more for it. Also, what is really great, and I just discovered this yesterday evening after a couple of beers, everything is really changing very rapidly within this landscape. So I did this presentation last week on Wednesday internally at Ordina, at the company where I work. And this function is using the serverless framework. And last week, so just a couple of days ago, functions created with the serverless framework were not editable inline in the editor from AWS. And yesterday evening, I discovered that it was editable. It was also actually recorded, so I double-checked to make sure that I wasn't having too much beers. But as it turns out, you can see the code. I'll have a code sample later because this is too difficult on this resolution. I think that's really cool, because it means that an external service where you just upload a zip file gets correctly interpreted by Amazon, and it's a change that they did. I didn't change this whatsoever. So I think that's really cool, cool feature. So the Lambda will be persisting something in DynamoDB. So as you can see here, I'm creating a DynamoDB object, and I will be persisting it.
May I ask a question?
Sure.
Maybe it's a very dummy one, but I will be more confused.
Mm-hmm.
You said that it uses DynamoDB.
Yes.
And if I have to store my data,
Mm-hmm.
my own data, do I store it in their database system or I use my own system?
So the question was, in this particular case, we're using DynamoDB, and if you want to store data, have a persistent state, do I store it in DynamoDB or store it somewhere else? And that's really up to you. So if you look at, for example, AWS, what we're looking at right now, it's very easy to store it in DynamoDB because we want to preserve some state. If you're using other databases, you can use all your other data.
If my data is huge, do I also pay for the database system to that?
Yes. You will also pay. You will pay for all the different services that you're using. But that's kind of a different use case because there's the running server from where you generally run your middleware. So you have your JBoss or your Tomcats running, and then you have your database system that also today you're paying for your database system, and it will be the exact same way of working.
But maybe it's also cheaper than using our own Oracle system, I guess, right?
I can confirm that it will definitely be cheaper than using your own Oracle system because most of the things are cheaper than your own Oracle system. No, but it's a very valid question. And if you are looking in this way of working, it's a comparison that you really need to do. Okay, we're paying X right now for this. We have, for example, JBoss middleware running on Oracle DB, and whatever it is, just part of your application landscape right now. And if you want to migrate everything, or in parts, you should not do everything at once. You can say, okay, maybe we're not using this part of Oracle anymore, and we will have less licensing for Oracle, less cost, less servers running, and we can use it in DynamoDB. So it's a very valid question, and it's an important comparison when you choose a supplier. Okay. So since our function will be storing data in DynamoDB, let's have a look at DynamoDB. And as I said before, I'm a big fan of DynamoDB because it's so simple. Just store data, done. Don't think about it. Don't think about whatever Oracle is forcing you to think about. I have two tables in here. The one that we're using for the demo is called hops. The garage car is something else. It's also open source. You can find it on GitHub. And you have the possibility to obviously look at the data if the screen wants to play nicely with me. Ah, come on. You should have a bigger resolution than the Beamer if you want to use well, basically anything. Command minus. Awesome. I have some awesome colleagues. So these are a lot of data that's currently in the database. I just have a quick look, but all what we're doing in the demo is parsing JSON. And you don't have to think about it, just store whatever's coming in DynamoDB, and it will create this JSON representation of your data. As I said earlier, there is a stream. In here you can see it, a stream configured if you're using DynamoDB, and that stream is going to trigger another Lambda. It's called process DynamoDB stream. So let's open it. And this is just our last Lambda that we're looking at. Very simple, just grab some information from the JSON that's coming from DynamoDB, and log it. So if you look at the logging, this is the logging. Let's quickly refresh it. So we had a request at 10:53. That seems about right. And here we see, okay, it's a function coming from out0 via web task to the NodeJS in AWS Lambda to DynamoDB. I'm not logging all of that, but you can see that it's just everything is available over there. And if we look at the logging, and that's very nice, here you will see that the build duration from the last Lambda is just 100 milliseconds. So as long as you're in the free tier, you're not paying anything for those couple of millions of seconds. And if you're not in the free tier, then you're paying the very, very small amount. And I don't even know how to pronounce that amount that I showed earlier. So 100 milliseconds is the build duration for this particular case. As I said earlier, I also want to show you Azure. And it's going to complain a lot because I stopped actually using it. I haven't looked in detail on this. So I, to be honest, didn't really get why they were sending me an invoice, because all of the other suppliers were not sending me invoices and I was not doing anything special. I just shut it down. If you want to have like a smaller demo about Azure, then just come up to me and then I can show you how it works. But I, for example, have a function here called getCars, and they also have a very nice error message. That's not what I wanted to show you. They have, again, if you look at this at the normal resolution, it looks very nicely. They have an inline editor that looks like this, and this particular one is also in NodeJS, and it will retrieve data from a database and log this information in here, as you can see from a couple of days ago. Again, the cool cars, and it will just log it. What you also get immediately with Azure is a URL to call your function. Why am I mentioning this in particular? Because with AWS Lambda, you do not get the URL. You need to configure the API gateway for that. And configuring the API gateway is really not very pleasant. And there, the serverless framework really helps, because in the serverless framework, you can just add some configuration to a YAML file, and it will generate the API gateway for you. It's really awesome. I'll show it in a bit. What's also really nice about Azure Cloud Functions is their integration tab in the function. So in here you can say that in the output and in the input I'm using the Azure storage table called in-table, and you also have an advanced editor. This is, for example, what the serverless framework will generate for you, and this is the code that it will be deploying to Azure Cloud Functions. The monitoring of Azure Cloud Functions is also rather nice if it's loading. It's been a while since I've executed because I don't like them sending me invoices. But normally you can see here, for example, this was a successful one 8 days ago. This was not successful. So you get immediate response of your particular functions, what you're doing with them. What I forgot to mention is the monitoring with AWS. It's located in CloudWatch. And you can, per Lambda, you can see Lambda, you can see, for example, invocations, duration, all of that is available. But the nice thing about the CloudWatch is that you can also create dashboards. So I've created a serverless hops dashboard. And in here, I just added some statistics. For example, if you want to see what's happening there, the returned item count from my DynamoDB and stuff like that. If you want to use this on the production environment, you also really should be thinking about your monitoring. Any questions on the demos? Anything that you would like to see that we haven't talked about? Yes?
I'm just wondering, when it comes to the actual code, I would be worried it would get quite complicated in there. Is there anything with source control or anything like that?
Absolutely love the question. I have a slide on that. No, the question was, and I'll address it right now. So there's a lot of inline editors in most of the offerings, and they're pretty good. The OpenWhisk one, I particularly like it. I like the syntax lighting and everything that it has. But the question was, what happens? Do they also have like a version control system behind them? And the simple answer to that is, well, no. I know this firsthand because I lost my code to the demo twice. Since I stated earlier that it's easier, it was not a lot of code, but you should really be using an external editor of choice. I particularly like Sublime. I'll show it in a bit, but you can use Atom, you can use whatever, you can use their IDE, you can use whatever you like. The inline editor is nice if you want to do some experimentation. You have a working function and you think, I need to log something over here because it's acting very strange. You just add a log line and then it's all working out great. But really, if you're doing any serious work that's more complex than what we're showing in the demo, just use an external editor. Trust me.
How do you typically deploy the code then from your own system?
That depends on the provider. For example, if you use the serverless framework, you can use their CLI and deploy it from there. If you're using in AWS it natively, you can upload a zip file. So there are a couple of ways of deploying your code that are dependent on the way that the provider is working. There are also some continuous integration tools that will help you with this. I think Apex is one. In my opinion, they're still relatively immature, but also the whole CI/CD world in itself is a very mature world. So I think that these tools will become very valuable in the very near future. More questions? Yes, sure.
Are there any companies that are deploying proper production systems that make money using this approach?
Okay, so the question was, are there any companies that are making money using this approach? That's a very difficult question since I'm not like following the market trends and stuff like that. But the best way to investigate is if you just Google the serverless framework, for example, on GitHub. They have been started for 10,000 times. There is a lot of activity, a lot of people who are posting issues or working together with them. So yes, I'm pretty sure that there are companies out there using it today. There is actually a CMS that is commercially available that's built entirely on WebTask. They also have very nice documentation on how they did it. And what I know in particular from one customer in Belgium, but I'm not allowed to say their name, is that they're using AWS Lambdas internally to create workflows. Because there are a couple of use cases that are very interesting from a Lambda point of view. There's like the collaborative economy that I talked about. Because you have unpredictable traffic. It might be a success, it might be a complete failure. And if you have to provision an entire system, then the cost just goes up. Another one that I like in particular is the IoT use case. Because if you, for example, have a large site and you have a lot of devices with sensors on it, they will be sending unpredictable amounts of data to you. So if you don't want to be spending a lot of time on the provisioning, then serverless is really a nice use case. I promised that I would show you some of the code, and you will agree with me that it's rather simple, or the demos are rather simple. This, for example, is one, as you can see, from IBM OpenWhisk, and this is just basically a NodeJS function that's going to use a promise to be executing. This is JSON, all of this is JSON, and it's going to post these parameters to this URL. Very simple. I was also talking about the serverless framework. This is an example of the serverless framework. It looks the exact same thing, but on the same time it's a bit different, because in here you see that there is like a function keyword, and in handler they're just exporting modules, the AWS module. So there are very small differences, but in the end it's still very similar. There's also a best practice regarding externalizing some configuration. For example, if you're using third-party modules, you should be instantiating it. That's a difficult word. Instantiating them outside of your particular Lambda, because as long as your compute container is up and running, this will not be executed anymore. If you're making, for example, database connections like the DynamoDB one, if you put this outside of your connection, then the actual execution of your function will be quicker and therefore cheaper. I talked about the serverless framework and how it will really enable you to set up, for example, the API gateway. And this is done very simply via a configuration file. So in here you have the AWS hop part. And just by adding this event, so it's an HTTP event with a method of post, it will create all of the strange things I personally find in the API gateway, and it will be readily available for you. When you deploy this function, you'll get your URL. This is really like time saver. Okay. Back to the presentation. If you like to have a more like an in-depth look to the code, the URLs are here available. I'll be publishing the slides as well. Some best practices. We have been talking about The Walking Dead. Who is looking at Breaking Bad or used to watch Breaking Bad? Ah, awesome, you're my friends. Who would like to end up when serverless like Walter White here? Oh, no, nobody. Okay, great. I have to be very honest with you. Serverless is still pretty new. A lot is changing. As I said earlier, there was a change in AWS Lambda last week, so when I first did this presentation. So the number of best practices is something that's really going to change in time. So right now, when you make your supplier choice, you should not do what I did and try to include all of them. That's really not a good idea. It's nice if you want to do a demo, but you should not be doing it, because monitoring all of your different functions in a complete system will become very difficult. Also look at what they're offering regarding pricing. Remember what I said about Microsoft and them sending me invoices that I don't like. Tooling is also very important. Right now, you should really be looking at like the serverless framework. There are similar frameworks available, but in my opinion, serverless really is the best one out there at the moment. Build and deploy and monitoring. For monitoring, I think that there are really some possibilities still available if you want to create something really cool, like for example, the possibility to have your one big system with all of your functions and then see the status of all of these, and then you can like drill down to what they're already offering. That would be very valuable. If anybody feels like doing that, please contact me, because I'd really like to see that. Also important regarding supplier choice is the execution time. Up until a couple of months ago, the execution time in AWS was limited to, if I remember correctly, 30 seconds. Right now, they changed it to 5 minutes. So this is changing. You should be very conscious about making a decision. If you say, OK, I have a very long-running function. For example, it's going to read a huge XML file on S3, for example, which is probably not a very good use case, but the execution time is limited. After 5 minutes, it will shut down. And then when I did this presentation last week, I got the question, oh, this is really cool. What about service level agreements? What is their promise regarding the execution time? Am I sure that I will be billed for 100 milliseconds? Or are they going to change it and bill me for 30 seconds? Well, the question is very valid. But the answer is not something that most of you will like. Right now, if you look at the AWS website, they say that this is still very new, and they're doing their utmost best to make sure that it's fast. I've been playing around with it with serverless for quite a bit, especially with AWS Lambda, and I have to be honest, I haven't been disappointed in the response times, but there is no formal contract saying that we will respond to you in that time. Of course, it's also in their benefit to make sure that it doesn't take 30 seconds when it's supposed to take 100 milliseconds. Yeah, sure.
For the previous slide, actually, I think something is missing there, or I'm curious about how it's with the IBM or Google, if they are available also somewhere like in China. Because Amazon, for example, I've been considering to use the Lambdas, and then I found out, okay, it's not available in China.
Okay, good question. So the question was about the different providers and what they're offering regarding the regions where you want to state. And that's still a problem, because as you said earlier, and that's very correct, Amazon Lambda is not available in all possible regions yet. They're changing that, they're updating this, but they don't have a formal roadmap, or not a publicly available formal roadmap, when there will be available in these different regions. If you want to look at the particular other providers, then you should maybe look at it in depth, but always keep in mind that they will probably be changing it. If you paid really good attention to the demo, you will see that actually I have a region problem, because I'm also logging the time difference between the execution. And the time difference, for example, between OpenWhisk and the Lambdas that I'm using is different. So I'm not getting very accurate logging. So it's something that's very important to look at. So excellent question. And yeah, you should look at it and make sure that it will change very often. There are people at the Amazon forums that also have been asking questions. I need to have this in this particular region. And AWS is listening, but it's not because they're listening that they're going to change it immediately, especially for you. Very valid question. I wish I had a better answer than this one. Okay, have a sip. As I showed you earlier, initializing of the services should be outside of the function call itself, because then it will just be quicker. And everybody likes to make sure that they're not built that much. Limit your function size, as I showed you. The NodeJS function and the Java function have a huge size difference. And this really has an impact on the startup of your compute container. So the smaller it is, the less memory you will need, and the faster it will spin up. Also very important, the memory that's being allocated to your function is something that you can configure on a per function base. So if you say, this is really important and I want to allocate a lot of memory for it, you will come in it will be a different pricing, but you're able to tailor the execution of your Lambda in that way. Same goes for the other providers. And as somebody asked, is there some kind of version control regarding the internal editors on their web pages? And they're nice for experimenting, they're nice for playing around with it. But really, if you're doing any serious work, use an external editor because you will lose your function. I lost it twice, so. And that was actually my last slide. I have no clue how much time I have left.